Hey YouTube, welcome to my channel. If you're new here and you want more maths content, then please consider subscribing. If you learned something, then hit that like button. I hope you enjoy my video. Looking at the basics of multiplying algebraic fractions. So, first one, simplify fully 1 over x times x squared over 2. Now what I'm going to do is I'm going to show you in the long way of what's going on, and then we're going to do the short way. So it's important that we see where things are coming from. So we have 1 over x times x squared over 2. Now we know, when we do algebraic, when we just do fractions in general, say I had 2 over 8, yeah? Now we're all pretty good at just saying, look, divide the top and bottom by 2, right? So you'd get 1/4. So we know that's 1/4. But why is that happening? The reason this is happening is because 2 is just the same as 2 times 1, and 8 is 2 times 4. So you can see a 2 in the top and the bottom, we could just cross them out. So that's essentially what's going on. When we say divide the top and bottom by 2, it's because we can rewrite each number as a multiple of 2, and then the 2's cancel. So basically what we're doing when we simplify by multiplying, we observe the top and we say, is there anything in the top that is the same as the bottom? If there is, we can cross them out. Yeah, and it doesn't matter if they're on different fractions either. Yeah. So in this case, this is where I'm going to write the long way. X squared, we know, is the same as x times x. So I'm just going to write them next to each other. Yeah. Now, what you see is in the numerator, there is an x, and in the denominator, there is also an x. So what we can do is we can just cross them out. Yeah, they cancel just like the 2's cancelled up here. So what's left? On the top, we have 1 and we have x. Now they multiply to just give you x. And on the bottom, there's just a 2. Yeah. So essentially what we're doing, we don't have to write x squared as x times x anymore. We know, I'll show you how we would do it now. We understand that x squared is x times x. Yeah, so we know without having to actually write it, we know that x squared is the same as x times x. So this x would cancel with one of the x's in the numerator. And what we do is we just cross out the squared instead. And we say, look, x cancels out the squared. So in the numerator, we're just left with x. Then you can just see the answer, x over 2. Yeah. So let's see how that works with part B. So we have 4x cubed a to the power of 6 over 3 times 9 over x squared a. Now you want to look in the diagonals basically. So, or you're just saying, look, what's on the top and what's on the bottom? Yeah, on the top we have the 4x cubed and the a to the power of 6, so we have the 9. Then on the denominators we have 3 and we have x squared a. So we're saying, okay, what on the top can cancel with things on the bottom? Well, we might be able to see straight away that there is the 3 and the 9. So we think, okay, what number goes into both 3 and 9? Well, we would all choose 3, right? 3 divides into 3 once, and 3 goes into 9 3 times. Okay, the next thing is, I can see an a to the power of 6, and I can see an a in the denominator. They will cancel each other out. Now remember what a to the power of 6 is. It's a multiplied by itself 6 times. So I've got 6 fingers up. So the a in the denominator will cancel with one of the a's. So we're left with a to the power of 5. Yeah? So how do we show that? We're saying, okay, this a goes into a to the power of 6, but it will remove one of the a's after cancellation. So instead of it being 6, it will be 5. Yeah, so like I said, the numerator a to the power of 6 is 6 a's being multiplied together. Shall I do that so you can see it better? But when you divide by a, one of the a's go, so we're just left with 5 of them. Yeah? So this a just disappears. We could just say it's 1. Now, what else do we have? The last thing we have is x to the power of 3 on the top and x to the power of 2 on the bottom. So essentially, you might notice that we're just taking away the powers. So can you remember you see 6 here? This was a to the power of 1. So we do 6 minus 1 to give you 5. Same thing here. X to the power of 3 in the numerator means you have 3 x's multiplied by themselves. Then you are taking away 2 of them because you're dividing by x squared. So when you take away 2 of them, you're just left with 1. So how do we show that? X squared goes into x cubed. It gets rid of 2 of the x's, so we're just left with x. So basically we're getting rid of the cubed and we're just left with x. So what's left? Now here's where when you write this, you want to write it quite big because then you can see everything. But we have 4, we have 4 times x times a to the power of 5, and we have times 3 on the numerator. So we do the numbers first. 4 times 3 is 12. We have x, and we have a to the power of 5. Divided by? Now on the bottom, everything cancelled. The 3 cancelled, the x squared went, and the a went. So we're just left with over 1. So that just simplifies to 12x a to the power of 5. Division. Now you know from year 7 that division is basically the exact same as multiplication. You just change divide into multiply and you flip the second fraction. That's it. So for part A, the first thing we do is we change the divide into multiply and then we flip the second fraction. Some people will say KFC, right? Keep, flip, change. So x squared over 2 becomes 2 over x squared. Now, this is what ends up happening. So, I've kept the first fraction the same, flipped the second fraction and changed the sign. But what students try and do is at the beginning, they try and cancel the x with the x squared like we did in the first question of the last slide. Do not do that until you have changed to multiply. Once you have multiplied, then you look at the top and the bottom and see if anything cancels. But here, it doesn't happen. So we have 1 times 2, which is just 2, x times x squared. So we're merging them. So we have 1x, and then we have x squared. So together, x cubed. So x times x squared is x cubed, and that's your solution. 1 over x, and then leave some space, because we want to say what we're timesing top and bottom by. Now we think so do you remember we did the 1 over 2 plus 1 over 4? Because 2 goes into 4, we chose the number 4 to be the common denominator. But here, x does not go into y, and y does not go into x. So there's no common denominator like the 2 and the 4 had. So the common denominator here is we just multiply the 2 terms together. So the common denominator, do one big fraction, we say is xy. Then what we say is, look at the first fraction. What do I need to multiply x by to make it xy? Well, the answer is y. But then I do to the bottom what I do to the top. Then for the second fraction, what do you have to times y by to make it xy? You just times it by x. So you times the top by x. Now what are we left with? 1 times y, which is just y, plus 2 times x, which is 2x. And that's your solution. Right, doing some harder ones. So express the following as a single fraction in its simplest form. But trust me, these aren't even hard. Yeah, they're not that bad. It's the same thing every single time. Yeah. So look, we have 2 over x minus 2 minus x over x plus 1. Now, what are we saying? We're saying, look, does x minus 2 go into x plus 1? The answer is clearly no. They're not multiples of each other. If they were multiples of each other, you would have on the other fraction 2 bracket x minus 2 or something. So it'd have to say x minus 2 in the other fraction if there was something common. Then it's like, does x plus 1 go into x minus 2? The answer is no again. So we need to multiply them to get the common denominator. So we multiply by x minus 2, x plus 1. Now again, we scale the fractions so that so that both denominators give you x plus 1. So what do you need to do? To the first fraction, we need to multiply it by x plus 1, which means we need to times the top by x plus 1 as well. So we have 2 lots of x plus 1. To the second fraction, we need to times it by x minus 2. So we have to times the top by x minus 2. So we have minus x lots of x minus 2. Again, what should we be doing here? Same as before. With this minus in the middle, let's expand it, see what we can do. So we have 2x plus 2, 2x plus 2. Then we have minus x squared plus 2x. Minus x squared plus 2x. All over x minus 2, x plus 1. Now from here, we can simplify the top. We usually like to write the x squared first. So we can say minus x squared, 2x plus 2x is 4x plus 2. Over x minus 2, x plus 1. Now the next thing you want to think about is, could you factorize the top? Now I know there's a minus x squared, but what we would do, so we haven't done this properly, but to factorize negative quadratics, what you do is you factorize out minus 1, and then you think, okay, can I then factorize what's left? If you factorize out minus 1, you're still thinking about what multiplies to give 2 and adds to give you 4. The answer is nothing. Yeah, so since nothing, so with 2 you only have 2 and 1. 2 and 1 can never make 4 in the middle. So it looks like we can't do anything with this one. So that's your solution. Yeah, nothing can be